Welcome back from the ad break, and let's continue with our lesson. So now we are going to be moving on to that first concept in our concept map, and that is representation of numeric patterns in tables and algebraically. So let's look at the representation of these numeric patterns in a table. Now, in our pre-knowledge questions, we did look at the pattern 4, 10, and 16, where we were required to find the next three terms. And if you remember, we had to find what the rule is. So now that number that we found that is adding on to these numbers to get the next term is the constant difference. Now, do you remember how we calculate this constant difference from our keywords? Yes, we will say that the second term minus the first term, or we will say the third term minus the second term. Now, us doing this will mean that we will say 10 minus 4, because when we are looking at our pattern there, that 4 is our first term. Remember, the term number represents the position of that number. So since 4 is the first number, that means it is the first term. And 10 is the second term, and 16 is the third term. So for us to get that constant difference, of which we did find of 6, then that means we are going to say 10 minus 4, and that is also equal to 16 minus 10, which gave us that 6. Now, if you remember, the next three terms in this sequence were 22 and 28 and 34. We obtained these numbers by using that constant difference of 6 that we found. Now, let's represent these numbers in a table. So here is the table, and we are going to represent these numbers in this table. So here at the top of my table, I've got the term number, which is term number 1, 2, 3, 4, 5, and 6. That's where we are going to stop. But as shown in our pattern, this pattern does continue over there. But let's just represent the first 6 terms. So as we've spoken, the first term is our 4. The second term is our 10. The third term is our 16. Of course, there our fourth term, our fifth term, and our sixth term. Those are 22 for the fourth term. And there's 28 for the fifth term and 34 for the sixth term. So that is us representing these numbers or this numeric pattern in a table. Let us see how we would represent it algebraically. Now, it has already been represented in a table, which is that table that we just filled out there. So as we can see our table there. Now, why would we need an algebraic representation? Well, as you can see, the table here represents only the first 6 terms. And as emphasized, we do continue with this pattern. So if you are asked there, what is the 15th term? So we know that 34 is the 6th term. What about the 15th term? Does this mean that you are going to add that constant difference right up until we get to term number 15? Well, you could do that, but what about term 100? Let's find an easier way to find that 15th term. The first question that we need to ask is, what is the relationship between the term number and the constant difference, as well as the term itself? So let's see how we can find this algebraic pattern. So remember, we are trying to find the 15th term of this pattern. Now, before we can find the 15th term, we need a rule. Remember, we need to find that relationship between the constant difference, the term number, and the term itself. So how can we find that rule? Now, the rule here would be that we are going to multiply the constant difference with the term number. Now, just to remind you that 4 was the first term, the 10 was the second term, the 16 was the third term, and the 22 was the fourth term. Of course, that pattern continues. But for us to be able to find any term here, we are going to take the constant difference, of which we have identified as 6, and we are going to multiply it by a term number. And in the end, we need to find a constant value that we are going to add or subtract for us to form that rule. Let's see how we are going to do this. So that constant difference we found by subtracting the first term from the second term, and we found that 6. Hopefully you can remember that. So now we are going to say for the first term, now we know the first term is 4, right? We know the first term is 4. And remember what the rule said? We are going to multiply the constant difference, which was 6, with the term number, which in this case is 1. Now we need to find that constant value that we are going to add or subtract. So what is 6 multiplied by 1? We know that 6 multiplied by 1 is 6, but the first term is not 6, the first term is 4. So if we say 6 multiplied by 1 gives us a 6, how do we move from that 6 to that 4? If you are thinking that we subtract by 2, then you are absolutely correct. So that constant value could be that we subtract by 2. But before we can confirm that this is the constant value that we are subtracting, we need to make sure that this works for all of the terms, or 2 or 3 of the terms, not necessarily all of them. Let's check with the second term. Now the second term, again, we are taking our constant difference, which is 6, and we are multiplying it with the term number. We are now working with the second term, and that second term is a 10. So we are going to say there 6 multiplied by 2, we know that this is a 12. Now how are we going to get to 10 from that 12? Yes, again, we are going to subtract by 2. Is this the same for the third term? Let's see. So now we have 6 multiplied by 3. We know that that is 18. But our third term is not 18. So how do we move from 18 to that third term? Yes, we are going to subtract by 2. So we have seen there that our constant value that we add or subtract is a minus 2. We are going to subtract by 2. So what conclusion can we make here? We have seen that we take the constant difference, we multiply it by the term number. See, we multiplied by 1, by 2, by 3. But when we are talking about any term number, then we are going to use a variable of n. So we know that we multiply the constant difference with the term number. And that, of course, is going to give us our 6n. But we saw that we are constantly subtracting by 2. So that is going to give us, of course, what is 6 multiplied by n? That is 6n, and of course we are going to subtract that 2. And that is our rule. 6 multiplied by any term number that we are working with, and then we subtract that 2. So how are we going to find that 15th term? So remember, we are just going to take the constant difference multiplied by the term number, and in this case it is 15, and then we are going to subtract by 2. So we can see there that term 15 is going to be 6 multiplied by 15, and then when we subtract 2, that is going to give us an answer of 88. Then we are going to work with a next pattern again. So this pattern, we also worked with it in the pre-knowledge questions. Now, what was the constant difference here, if you can remember? Well, that constant difference was a minus 3. If you can remember, we did find the next 3 terms, and that was a -1, a -4, and a -7. And remember, we found these next 3 terms using that constant difference of a -3. So how are we going to represent this information in a table? Again, we have the first 6 terms. Of course, this table does continue, so we are just going to represent those terms. The first term is an 8, second term is the 5, third term is a 2, the fourth term is a -1, the fifth term is a -4, and the sixth term is a -7. And that is how we have represented those number patterns. So what about when it comes to the algebraic representation of this pattern? So there is that table that we have already filled out. But again, what if you are asked for the 100th term? Now you have to ask yourself, what is the relationship between the term number, the constant difference, and the term itself? Let's quickly go and find that 100th term. But of course, we would need to find that rule first. Now, do you remember how we find the rule? We are going to take the constant difference, multiply it by the term number, and find that constant value that we are going to add or subtract. So what is the constant difference in this case? Do you remember how to calculate that constant difference? Yes, we are going to say the second term minus the first term. In this case, this is going to be our 5 minus our 8. And of course, we've already discussed this is the negative 3. Remember that the constant difference can also be found by saying the third term minus the second term. This would be 2 minus 5. And again, we get that constant difference of negative 3, just to show that it is the same difference throughout. So how are we going to find that rule? Remember, we are going to say the constant difference multiplied by the term number. So let's start with the first term, which we are going to say the constant difference, and we are going to multiply that by 1 because we are working with that first term. Now, what are we going to add or subtract so that we get to our first term, which is 8 in this case? So negative 3 multiplied by 1 is, of course, a negative 3. But from negative 3, how do we get to an 8? Well, if you are thinking that we are going to add an 11, then you are absolutely correct, because from negative 3, we add 11 so that we can get to a positive 8. Let's check if that constant value that we are adding is the same with the third term. We can even take the third term. You do not have to take consecutive terms. But we are going to say now a negative 3 multiplied by the third term, or a 3, sorry, a negative 3 multiplied by a 3. What are we going to add or subtract so that we get to our third term, which is our 2? As we can see, there is our third term. So how are we going to get to that 2? Remember, negative 3 multiplied by 3 is a negative 9, correct? And from negative 9, how can we move to the 2? Yes, we are going to add 11. So we can see that our value that we are adding is the same and it is constant. So what does this mean for our rule? It means our rule, we are going to take the constant difference multiplied by any term number, and we are going to add 11, and that of course is going to give us any term that we are looking for. And in this case, since as well we are looking for the 100th term, so we are going to say term 100 is going to be equals to, that's a negative 3. We are going to multiply that with 100, and we are going to add an 11. So what is negative 3 multiplied by 100? Yes, that is going to give us a negative 300. And of course, when we add 11 onto that, the answer is going to be a negative 289. And that, of course, is the 100th term for this pattern. Let's quickly go to an ad break, and then we'll see you just now for the rest of our lesson.